What needs to happen to prove a quadrilateral is a parallelogram is you got to show me one of the properties exist. And how many properties were there? 5. Now I want to talk about those 5 real quick. One of them you're probably never going to use, and that is consecutive angles or supplementary. You're probably never going to use that to show me a quadrilateral is a parallelogram. So you'll see, how do we still have 5 up there? 5 ways. You'll notice number 5. All right, take a look at number 5. This is a special way to prove a parallelogram. All right, special case. And that is if you can show your quadrilateral has one pair of opposite sides congruent and that same pair are also parallel, you got yourself a parallelogram. All right, so please be aware of this special case right here, number 5. All right, any other properties? Opposite sides congruent, it's a parallelogram. Opposite sides parallel, it's a parallelogram. Diagonals bisect each other, it's a parallelogram. All right, and also now this special case. If you can prove to me one pair of opposite sides congruent and parallel, you have yourself a parallelogram. All right, please do not write down special case in the reasons column. All right, we'll show you what you need to write down. All right, before we dive into a proof, do we have the ability, if I give you information, can you tell me, is that enough to say that's a parallelogram and why? Number 1, angle SPX, this angle here, is congruent to TMX. That angle right there. And TPX congruent to SMX. Is this good enough to say it's a parallelogram? And we better back ourselves up. Okay? Better back ourselves up. Well, where does this lead to? Let's start with the 2 angles I marked originally. These 2 right here. What type of angles are those? Alternate interior, what's it lead to? Alternate interior angles, congruent leads to parallel lines. And also these 2 green ones I marked with 2 arc marks. What type of angles are those? Alternate interior, so that leads to parallel lines. And now why is this a parallelogram? Opposite sides parallel, all right? So here's what we're going to write. Opposite sides parallel, the opposite of what we've wrote the last 2 days. Opposite sides parallel imply a parallelogram. Now, be honest with me. Did anybody think this was going to be, oh, I'm going to add those 2 together and I could say opposite angles are congruent? All right, I don't blame you. Here's why. Read it. Read it up here. If both pair of opposite angles, this would only give you 1 pair. You guys see that? You need both pair congruent to say it's a parallelogram. We all good. So this right here, take a look. This right here wouldn't cut it. You need both pair. All good. All right, next one up. Let's erase the diagram. New information. SX congruent to XT. SM congruent to PT. Enough information to say it's a parallelogram. Let's roll here. Is that enough? Let's go to the, so we don't fall asleep here. 9, what are we thinking here, 9? Enough info? Already, what did I give you? How many sides are congruent? 1 pair of sides, that's not going to cut it because I need both pair. How many diagonals are getting bisected? 1, I need both pair though. So nothing. Everyone agree? I can't do anything in this case. All right, so this is a big no. No parallelogram. Everyone see why? There's just not enough information. Next up, PX and MX and SX and TX. What do I have here working for me now? Here you go, 16. What do I have working for me here? Correct. So that means it's a parallelogram. So diagonals bisect each other, imply a parallelogram. All right, next up, SP congruent to MT, SP parallel to MT. Good enough to make a parallelogram. Good enough. Here you go, 23, good enough? Yeah, that's the special case I just talked about. Everyone see the special case. What same pair are both parallel and congruent. So here's what I'm going to write in the reasons column in the proof in a couple minutes. One pair of, and this is key, I'm dead serious, this is key, this next word. You can't put one pair of sides. Because you could be these two and that's not right. They have to be what? Opposite sides. One pair of opposite sides, congruent and parallel, imply a parallelogram. That's the reason we use for this special case. How do you feel, all right? You and your group right now. How many did I put there? 8 of them? Let me know if it's a parallelogram or not and write the reason if it is. Go ahead, 2 minutes. Tell me if it's a parallelogram or not and write the reason if it is. If it's a no, just write a no. Here we go, number 7. I won't write these out. I'll just write yes or no, but make sure you have the reason down as well. 27, what do we got? That's a big yes. Why? Diagonals bisect each other. It means it's a parallelogram. How about 8? 1, how about 8? No, you only have one pair. You need both pair congruent. How about 9? A lot of going on 9, huh? 11, what do you got? That's a no. That's a no. I would need this congruent side to be down here with the parallel side. How about 10? 17. Yes, why? Thanks a lot there, Thug Life. Both pairs of opposite sides, congruent. Good. You really look hardcore with the hood on. You're scaring me, Teddy. Moving on. Number 1, how about 11?
Yes.
Why?
Because if both pairs of opposite sides are parallel, then it's a parallelogram.
These are alternate interior angles, and if they're congruent, that means I have parallel lines. Opposite sides parallel, yes, leads to a parallelogram. 12. What do you got for me? 7. What do you got? Oh, one job. 5.
12?
Yes.
No.
No, why not?
Because only one pair of opposite angles.
And we need?
2.
Great job. 13. 17. 13, yep, speaking of special case. Picking that up. Good, yes, nice job. Yep, one pair of opposite sides congruent and parallel. Nice job, Teddy. You're on fire today. You can explain to him later. 26. 14, what do we have? 26. No, only one pair, right? All right, everyone good on identifying it? We're all good? We ready to go to an actual proof now, seeing if it's parallel or not, a parallelogram. First one's not too bad. First one is not too bad at all, just to get the basics. Okay, first thing, it's written in there already, the givens, perfect. See where it says PQRS is a quadrilateral? You have no properties, other than it's got 4 sides. Quadrilateral does not mean opposite sides congruent or opposite sides parallel. All this is telling you is it's a four-sided figure. That's it. All right, turn it into a parallelogram now. All right, turn it into a parallelogram. And this one's not too bad. It's the second one we're going to have to work our tail off for. I got 1 congruent to 2, 3 congruent to 4. Let's make it into a parallelogram. All right, 1 congruent to 2. Where can you get from 1 congruent to 2? Better get these lines specific for me. 1 and 2 being congruent leads to what? 6 leads to? Which ones specifically do 1 and 2 lead you to? PS, parallel to QR. Everyone all right? That's where 1 and 2 lead to. I always worry about you guys not finding the correct lines. What's a good reason why right there? What's a good reason why? 19, what would be a good reason why to say they're parallel? Just like you never left. Alternate interior angles congruent. Make sure you got the word congruent there. Imply parallel lines. And I'm also going to put something else in step 2. 3 congruent to 4 leads you to what? 7? Oh, 1 jab, baloney. 8?
SR is also, yeah.
Don't get rattled. Come on. SR parallel to?
Is parallel to
PQ. There you go. Same reason. Everyone good so far? No issues? Got a parallelogram? Do I have a parallelogram? Yeah, I have a parallelogram. Yeah, so step 3. PQRS. I appreciate it if you don't use that little box. I allow you guys to write out parallelogram. I don't have you guys write it out. I allow you to shorthand it. Reason why it's a parallelogram. Here you go, 14. Why? There we go. Opposite sides parallel imply a parallelogram, the reverse of what we've been writing the last 2 days. Not too bad, right? Just wanted to get you guys, get your feet wet there. Any questions before we go into this beast? All right, let's do it. Let's do it. Ooh, how about this? Given a parallelogram, prove another one is. So I'm going to start out, and this is where the highlighters come in handy. I'm going to highlight which one is a parallelogram, which one is. So that tells me you can apply any property you want to that highlighted quadrilateral. And we are also given that AE congruent to CF. All right. Whew. I need your help getting some sides. Getting some sides parallel or congruent. Because everyone take a look. This one inside, we need to make a parallelogram. So you're going through right now. Can I get opposite sides congruent? Opposite sides parallel. One pair parallel and congruent. There's actually a good thing about this proof. Multiple ways to do it. Multiple ways to get that middle. And I'm sorry, I know I usually give you guys a lot of flexibility and creativity and do what you want, but we're going to do this one way because I want to show you a little shortcut here. All right, I want to show you a shortcut at the end. Vincent, what do you got? DA is congruent to CB. I am actually not going to go that way. Just so you guys know, I'm not proving any triangles congruent here. You can do that. Hey, you can do that. There's the way to do it. Because I want to show you this shortcut at the end, I do not want to prove triangles congruent here. There's a different way I'm going to do it. Can you get me DF and EB congruent? That's what I want first. What, Emma? Sure, go ahead, Emma. Yep. You can stop talking. I'm good. Thank you. You've done enough damage. DC congruent to AB. Nice job. Why is that true? Now, hey, now we really got to pay attention to detail here. Because now we're using theorems from yesterday and then today, and I don't want to get the order mixed up. What's it going to be here, Emma? I got to start it out with what, though? What made those opposite sides congruent? The fact that I told you that ABCD was a parallelogram implies opposite sides congruent. And then what am I doing, guys, with those sides and the sides I gave you? I'm subtracting them. Nice. DC minus FC is equal to AB minus AE. Subtraction. And then, yes, substitution. To say that side DF is now congruent to side EB. Okay, I want to just make sure we have two ways we can go here because it's almost a parallelogram, almost. Two ways we can go. We can prove the other pair of opposite sides. How do I transform this into a parallelogram? Because I already have these sides. So prove the other two opposite sides congruent, which I could by proving the triangles. Or I could go the special case I showed you today and show these congruent sides are also parallel. And that's the way I'm going to do it. Okay, and I'll show you why. This is where this shortcut comes in. Everyone ready? Because I think you're going to like this and you're going to use it a ton. What else do you know about side AB and side DC? We said they were congruent. They're also parallel. Ready? Watch this diagram here. Two parallel lines. Two parallel lines. Are these pieces still parallel? Even though I shortened the line, are they still parallel? Everyone agrees they are? All right, what if I do this? What if I make this even longer? Are they still parallel? Yes. I'm trying to show you guys, going back to that proof, if DC and AB are parallel, shouldn't the shortened pieces also be parallel? Yes, and that's a theorem I'm going to give you today. All right, so the first thing you need to tell me is the originals were parallel. So I need to show you DC parallel to AB. And let me hear from somebody, why is that fact true? 29, go rolling deep. Thanks. Now, how do I want to show that the pieces of those lines are parallel? All right, you got it. So now I want to say DF parallel to EB. Everyone ready? How do I show the shorter pieces are parallel? I'm going to use this new theorem that says parts of parallel lines are parallel. Parts of parallel lines are parallel. And this can only be used for parallel. Some kids try to get a little crazy and write congruent instead. Parts of congruent lines are not congruent. All right? Or parts of parallel lines are not congruent. It's only parallel. Okay? What do you got back there? What? Can I keep teaching? All right, I would appreciate that. Because yes, there is. You just keep along for the ride, all right? Anybody else got some words of wisdom here you want to give to everybody? Let's finish this proof. Because now you proved the same pair congruent and parallel. So I do have a parallelogram now. So EBFD is a parallelogram. What's the reason? I know this is a longer one. Sorry, you have to write it down. But what did I just show? One pair of opposite sides. What did I show that one pair of opposite sides? Congruent, not just congruent, and parallel imply a parallelogram. Okay, so two theorems. One we already used. All right, one we have already used. And that is parts of parallel lines are parallel. Teddy, go ahead, ask your question again. So basically, in our last proof, if you knew DF and EB were parallel and you wanted to get the longer segments parallel, and your answer is you're darn right there is. All right, except I don't use the word parts. I use the word extensions. Extensions of parallel lines are parallel if you want to go from smaller to bigger. All right, use those. They're great. Use them. All right, use them a lot. All right, those two shortcuts. All right, get going. Get going. Please, again, keep looking at the answer key. We got one more day of these tomorrow.